Hello everyone. Today I'm going to walk you through porting a Puppet Labs module to the Cloud CI that the IAC team uses. So the Cloud CI has a couple of major components. The two most important ones are the GitHub Action workflows. These are running on Microsoft's public runners, and the provisioning service. The provisioning service, a container that's currently running in GCP. This is able to provision machines that can be accessed from the runner to run the acceptance test. In order to interact with the service, we use a provisioning task. It's part of the provision module that's used with Litmus. One thing to note is that we have a couple of strict limitations in place before we can consider porting a module towards the Cloud CI. One of them is the part that there is a strict validation from the provisioning service. This would allow provisioning machines only to repositories that are part of the GitHub's Puppet Labs organization. Second part is that the module itself needs to be PDK compliant, and the acceptance test need to be ported to use Puppet Litmus. Let's go to the demo here. For this demo, I'm going to use the Puppet Labs testing module. This is a copy of the MOTD module, basically. However, this repository is already PDK compliant, and its acceptance tests are running using Litmus. For this demo, I prepared a branch here. It's called Pour Demo. In this branch, you will see that the repository doesn't have any GitHub workflows set up. So let's move to the terminal here. So let's check the status of the repository. We are currently on the Pour Demo branch. Let's run a PDK validate to ensure that the module is valid from the PDK standpoint. Currently, we're using Ruby 2.6.3 with Puppet version 6.22.1. This will run all available validators. One thing to note is that this repository, this module, doesn't have any bold tasks. So the task validation basically is being skipped. Okay, so now that the validation is complete and we can see that everything is okay from the standpoint, let's take a look at the available rake tasks. So if the module is configured to use Puppet Litmus for its acceptance testing, we should see in the rake task list the Litmus associated rake tasks. These rake tasks are the ones that are being actively used inside of the GitHub workflows to provision the environment, install the Puppet agent, install the module, and run the different test suites. So before we move on to the sync YAML file, we should probably check the metadata of the module. So this is very important because the GitHub workflows use the metadata information to generate the test matrix. In order to validate this, we need to ensure that the operating system name and the operating system release are consistent with the information that is present in the matrix from metadata script. In order to check that, we can take a look at Puppet Litmus and take a look at the script that generates the metadata. Let's take a look at that the matrix from metadata script. So in Puppet Litmus repository, in the XC folder, we have matrix from metadata version 2. This script contains two hashes. The first one is the image table. These are the images that will be provisioned using the provisioning service. So if the metadata contains information on different versions of Red Hat, these are the images that will be provisioned for that particular test. For everything that's open source, we still use Docker. So with Docker, we have the Litmus images set up in place. These are publicly available images, can be accessed from the Docker Hub. This is meant to basically reduce the cost and allow a flexible environment for acceptance testing. Let's move back to the demo. So now that we know that the metadata is okay, let's edit the sync.yaml file. At the end of the file here, we'll add in the workflows that we want to PDK to generate for us. So we're going to add in the nightly workflow, the PR testing workflow. So these are both acceptance test workflows. We have the auto release workflow. This is a workflow that will run at the end of each week, and if there are changes in the repository, it will create a pull request with a release preparation. This uses the experimental PDK release prep feature. We have the spec testing workflow. This is solely for unit testing. And we have the release workflow. This is basically the publishing workflow. This workflow can be manually triggered, and once the release prep PR has been merged, it will use the version of the module to tag the repository, build a tarball, and push it to the Puppet Forge. Okay, so now that we have these workflows in place, we can run PDK update, and PDK will fetch for us all these files. The information for these files is available in PDK templates. So as we want to add these files in, and there we have it. We have the 5 workflows. Now, for demo purposes, I'm gonna modify one of the workflows so it will trigger a run when we actually push to the branch. This is solely for demo purposes. Let's allow the PR testing workflow to be triggered also whenever you push to the repository. So now we add in the changes. And push to the branch. As these changes have been pushed, let's take a look at the testing repository. We should see in the Actions tab that the action has already been triggered. So we'll have the setup of the matrix, and then all of these OSs are currently being set up for testing. Whenever the setup matrix doesn't find a particular image that's specified in the metadata, we'll have a warning over here. So we'll know exactly what OSs are not currently being tested. So all these workflows are available in PDK templates in the module root folder, GitHub workflows. These are the ERB templates that PDK uses to set up these files for us. So we use Honeycomb mostly to gather the data from all these tests and have a centralized source of information. For information about that, please see the Honeycomb demo. So let's take a look here at the provisioning environment. So whenever the test environment is being created, we use litmus provision rake task. This will receive as parameters the provider and the image to use. So for Docker, it's going to use the provision service Docker provider and the litmus images. For the provision service, it will use the provision service provider and the GCP image. Once the provisioning is complete, we'll have the agent installation step, module installation, and acceptance testing. So let's take a look back at the workflows. So the workflows now just finished on some of the open source ones. If we take a look at the Debian 10 one, we'll see that this finished in 1 minute and 46 seconds. We can compare one of the Docker container runs with one of the provision service runs for consistencies. So in this case, the provisioning took 1 minute and 7 seconds, and for Red Hat 8, 1 minute and 15 seconds. So at the end of the provisioning, we'll have the Bolt inventory file here with the public IP of the machine, user, password, and a unique identifier that's being used by the provision service to monitor the box. For the Debian one, for example, after the provisioning environment, the inventory file contains the connection information on the local host, so basically on the GitHub runner. Okay, so with the machine provisioned in GCP, SUSE Linux finished the tests in 4 minutes and 37 seconds, compared to around 2 minutes for the Docker container. So, thank you for watching the demo. For more information, please see it at any available blog post at the IAC public webpage, or reach out to the IAC team. See information about that available there. So, thank you.